entities. So the one is we got the symbol, which is actually the entity that is going to be used in the schematic. We got the package, and which is the footprint of the particular device, and we actually have the device that is actually the collection of footprint and symbol, and also represents the definition how the pins and how the pads are connected to that specific device. Another problem that I've seen and I've received a lot of questions about it is how do you generate, or how are you going to do let's see, valve PCB sockets, and this is something I will show you today by using a small web application. You can actually do it by hand, but it's better to have it made by and generate a script by a small application on the website. So let's see. Okay. So what we're going to do now is we are going to actually start and build a device. So you have to keep in mind, like I said last time, Eagle is using layers for all the elements that are going to be used inside of it. So we are going to make a new symbol. Okay. Yeah, I would like to create a new symbol. Again, don't forget about the grids, and the grid it's actually going to dictate how close or how far. It's the minimum distance between the elements. So if you are going to use dip sockets like 8-pin dip sockets or 14-pin dip sockets or 16 or any type of dip sockets, usually the standard dimension between the grid and between the centers of the pads, it's 2.54 millimeters. But this is just something that I came up with now, so it's not generally true for all the parts. And what you are going to do, and what you have to do, is actually go to the data sheet, take a look at the mechanical specifications, and then according to that mechanical specification, you'll have to design the PCB footprint and everything else. Regarding the symbol, regarding the symbol, the grid is going to dictate how the symbol is going to be arranged inside the schematic. And don't go into a pitfall and design the symbol with a very strange grid. With the grid command, you can actually display the grid setting window. So don't go into a pitfall and use one grid in the symbol and use another grid in the schematic. You might be lucky and you might use it, and everything will be just fine. But in 90% of the cases, going with different grid settings from symbol definition to schematic is going to bring a lot of troubles, because you will not be able to actually connect with nets the pins of the devices because of the grid differences. You can actually correct that to an extent, pressing down the control key, but and using the Alt key and using the alternative grid. But it's actually better to actually start with the correct setting from the beginning, and not to think about it. So what I'm going to do here is I'm going to set grid for 0.01 to 5, or you can go either with bigger settings or smaller settings. Keep in mind that this grid setting will be used in schematic for the symbol, and the grid setting that is used in PCB footprint will be used in the PCB part of the eagle. So the two settings will not have to be identical in the schematic and in the PCB, but they will have to be identical in the schematic with the symbol definition and in the PCB definition, PCB footprint definition, and in the PCB design part. So regarding the symbols, I don't know. You can actually. I recommend you to use the standard symbols for everything that you're going to do, because you can actually go ahead and draw a square and call it's an op-amp, but maybe it will be you'll be the only person that is going to understand what is there. The symbol, it's going to be defined on the symbol layer, so you can actually draw it and choose from here. You can choose the width of the line. So I'm going to be 0.01. I've told you again, and I would like to repeat myself, do not use metric values or metric grids or anything like that, because 99.99% of the parts are defined in imperial values. And if they are not, well, make yourself a nice good and go ahead and put it in the change it in the imperial values, because you will have quite a hard time by using metric, either by parts not aligned, or you'll not be able to actually go with a trace from one pad to another. So what I'm going to do here, less talking, more working, I'm going to define one of the simplest symbols, and that is the resistor. It's advisable so you will actually keep the origin of the grid. If you're going to keep the origin of the grid in the middle of the symbol, that will be a lot better choice, because you will be able to actually click on it and then move it to where you like, and you will always have the origin of the symbol identical with the origin in the symbol definition. Oops, just a second. Okay, let's see. If there are any questions until up to this point, I'll be glad to answer them. So don't forget, post it on chat, and I will answer them. Okay, let's see. Marcus, I'm not recording this. I was going to. I forgot again. So I'm going to let's see if I can do this. Just a second. Just a second here. Let's see if I can. What I don't understand is why I don't see. Okay. Okay. Marcus and Dwayne, I gave you both the right to record this from this moment up, so you can actually record it if you like. So yeah, sorry about this. I always said that that I will do that and go on and record the session, but I was forgetting it. Okay. Excellent. So I'm going to define right now the most simple symbol that you're going to ever use in electronics, and that is usually 2-pin devices, and that will bring you to resistors and capacitors. And after I'm going to show you this, I will also, as I told you, and if we're going to have time, I'm going to show you how to define sockets for tube applications. Okay, so as I said, it's better to have the origin of the grid identical with the middle of the part, or whatever piece of the part you would like to be in the origin, because it will be actually quite much more easier to have it selected and then moved around. It will be, you will see, it will be much easier than to have to go into a corner, click on it, and then move, and etc. etc. Usually, what you are going to do, it's try and define the symbol as correctly as you can from the electrical point of view and the standard point of view. Is the best thing to do, because after all, when someone is going to read the schematics, and especially in the industrial environment, you will be sure that everyone will understand it. You can, as I said, you can go with your own symbols, but that will be quite unnecessary. Another thing that you have to do at this point, because every symbol, it will need to have pins where you are going to connect the nets, and you will have to add that to your symbol design, and that is either by accessing the icon here on toolbox. You got a little tooltip going with pin, or by this. So also here, as I told you last time, you can define your own macros from the keys, and you can actually, I don't know, Control Shift and B will actually display the pin dialog, and etc. etc. So you can actually go on and have your key bindings defined everywhere. It's much better to use the keys than to actually go with the mouse and select something from the toolbox and then go back to the design. Here you have many types of pins. You got points, you got a short, medium, and long pin. I guess this is a middle one, and a long one, it's quite long. And you can actually, if you are going to use the electrical rule check, but I will have a total different webinar for that, because it's a little bit difficult to explain it in such a short time. You can define the direction of the pin, and that would be quite important when you are going to use electrical rule check, because the ERC is going to actually read the type of the pin and expect in that position to be either ground or in or out, and it will actually going to give you a warning about the fact that a pin is unconnected and it should have been connected, or a power pin is connected to I don't know, to a signal net, and etc. So it's better to have them defined from here. The general type pin is I/O, so it's input output, and it will be regarded as a generic pin. So nothing will be checked against the ERC. So we are going to use a short pin here, and you can actually put it like this. So you have two pins, and at this moment you can actually go on with name command, go on and rename the pin, because by default is P US dollar sign and 1. So I'm going to use it in 1 and pin 2, because it's much easier to see it that way. You can actually go on in properties, and you can actually choose on which of the two sections of Eagle, like PCB and schematic, the pin name is going to be displayed. Is either it's pin or by pad. if you are going to let them both here, on both sections of Eagle CAD design, the pin numbers will be displayed. So I'm going to usually I'm taking off. I think that I take them off, especially for this kind of parts. Okay. So now that you have defined the symbol, you will have to actually save the library. So what we're going to do here, okay, and we're going to leave it directly here. And okay, so the symbol and the library is created right now, and you can add unlimited number of parts and symbols inside of it. I do not recommend you to add all the parts and symbols inside one library, because it will actually become harder to be managed over time when you're going to use a lot of parts. So it's better to have libraries that are split in functional devices like transistors, ICs, special devices, switches, etc. It will be much easier to be managed in the future. Okay, so we have our symbol defined here, and what we are going to do next, we are going to define. Oh, yeah, almost forgot. So another thing you'll have to define is the placeholders for name and value, and that will actually again will dictate how the name and value of that particular part will be displayed, either in a schematic or in the PCB. It's a little bit counterintuitive how this is going to be made, because not even in the Eagle documentation, it's not something clear stated about it. As far as I remember, I didn't read the new ones, but on the old ones, it wasn't clearly stated that name and value is going to be defined with some placeholders you would expect to actually be there and use them. Well, it's not the case. So what you're going to do is actually choose a text or go on and type text. I'm going to do this dual thing where I'm going to choose the tool from the toolbox, and I'm also going to type the comments, because at least in my opinion, the comments are a much better way to actually work with Eagle than to click on the toolbox. So we got text, and what you're going to do, is going to be smaller than sign, and you're going to type name. And you're going to place this not on symbol. You have to pay attention here. You're not going to place this on symbol. You're going to place some names layer. Okay, and from this point on, you can actually go on and set text, the size, the ratio, line distance. It's not something you'd like to go with, because it will actually modify the scale of the text, and it will look pretty bad. The font, I'm always using vector, because I had some problems with proportional and fixed, especially with the fab houses and at Gerber generation time. So it's better to use vector. It's an inherited font type from the DXF compatible design suites like AutoCAD and stuff like that. So yeah, if you're going to use vector, it's going to be fine for any PCB fab house in this world. Another thing you'll have to do is take a text and go smaller than and type value, and that placeholder will actually be and don't forget, put it on the value layer. That placeholder will actually be the value that will be is going to be displayed on the schematic. Okay. Okay. In case you have any questions until now from at this point, please put them on chat, and as I said, I will gladly answer them. Okay. Excellent. Okay. So after you define your symbol, you're going to actually define the footprint. And as I said, the footprint is translated into a package. So what we're going to do now is we are going to define new package. Again, keep in mind about the grid. I know I'm getting a little bit psyched about this, a little bit psycho, because I keep telling you about the grid. Well, if and when you are going to do so more mistakes, and so a bigger number of mistakes like me, over time you'll actually understand that the grid is quite an important feature. So we're going to use the grid. Okay, and usually I'm using 0.0125 inches. That would be, if my memory serves well, 125 mils, and that will actually accommodate a very wide number of SMDs and through-hole devices alike. You can go on and have a even smaller setting than that if you are going to use parts and devices that have a very fine pitch, and you will not be able to actually connect the traces between the pads because the grid is too big. You can go on and disable the snap to grid feature, but I don't advise that. In any case, stick to the grid. The grid is the best way to have a nice and a nice looking design, and also a functional one, because you can make anytime you can make a mistake and go over a certain point or certain angle, and it will not be such critical in audio design, but in a high-speed designs that would be quite unacceptable. Okay, so we are going to define this, and at this point, again, you can draw the package, and the package actually is a little bit more complex from the components point of view, but you have to decide at this point. You have to decide, generally speaking, at this point, what is going to be a top placed component, or is going to be a bottom placed component. Of course, you can actually change that at design time by using the mirror feature, and that will actually change the component of being a top placed one or a bottom placed one. But it's better to start from the beginning with a clear image in your head. So the layer that is going to host the package outline is going to be either top place or bottom place, 21 or 22. But being a resistor, we are going to use the top place. And we are going to start and draw the outline. At any given point, you can actually, you can actually go on and change the dimension for, yeah, I have a little bit of OCD, so I like to be in place. Okay, so you can actually change the wire width and anything that's you can actually go on and have it continuous or a long dash, short dash, dash dot. I will show you right away. So you have actually the placeholder for the part, and you're going to go on and click change. Okay, and here you will have a list with what you can actually change for this in this particular module of Eagle. So what we're going to do is going to go with 16 mils, right click and change group, and that will thicken a little bit the outline of the part. Okay. You can actually, especially when you're having elements like this, you can actually go on and copy them. Okay. Another thing that you'll have to define will be the silk screen part number and value that is going to appear in the PCB. And as I told you, schematic and PCB modules are two different entities that are using. You can use different settings, but it's not advisable to use different settings. It's better to have a consistency from start to end. But you can actually use different settings, and it will be quite okay. The only connection between schematic and PCB module will be the fact that it will be the forward annotation. So actually, if you're going to change a value in the schematic, it'll be the PCB will actually be updated in an instant. And also, if you're going to change a footprint or a part, you're going to delete a part or add a new part, etc., etc. You are going to have updated both sides. Okay, so why I told you this is because even if you added the name and value in the symbol, you are going to have to have it. Oh, come on. Okay, so we are going to end it in 10 minutes. So fast forward. Okay, even if you decided to, you will have to define it here also, the placeholder. So you are going to have less than, okay? Yeah, my words exactly, Marcus. Yeah, my words exactly. So we are going to have a name. The placeholders are the same, so it's quite easy. It's name, and that would be placed on. You'll have to pay attention. Not that it's something bad to put the name on the dimension layer, but it will get kind of, I don't know, hard to manage after a while. So you are going to use the top names layer, and you are going to place it there. And another placeholder is the value. Okay, so I'm going a little bit fast forward here. And we are going to place it on top values. So the names, the top names is 25, number 25 layer, and number 27 is the top values. And you can actually place them whatever you want, but it will not make a difference. They will appear in the same place. Okay, so another thing you'll have to define is the pads. So you can actually go on and choose the type of pads from the top panel, and I do recommend for parts that have two pins like resistors or unpolarized capacitors, etc., to go with the round pad. It's the best choice you can actually do. Because a round pad will have both the mechanical strength and I don't know, the electrical correctness to be used. You can go on and use other type of pads like a square for marking a positive side of a capacitor or anything like this. I would not recommend you to go with the offsets one and also with the long pads like this. I don't like them. They're quite in the way, especially when you are going to design the PCB, because it's not actually it's more it's longer than it's wider, and you'll have some problems when you're going to route the traces. Okay, you can actually go on and change the diameter or the drill, and that it will be very important because you'll have to look at the mechanical data sheet and see what is the diameter, what is the drill for the pin. Usually for 0.25 watts I'm using 0.8, and because right now I don't remember, so I have 0.8 or 0.9 millimeters to inches. That would give us 0.035, so we got 35 or 354 mils. So we are going to choose here default value of 354. So we have 354. Okay. And the diameter, you can go on and make it a little bit beefier if you like. So we are going to have it 0.7. The annular ring, I do recommend you to have it beefier, especially if you're new in the business and some parts are going to be shifted and will be replaced often for tests, because having a bigger annular ring here will enable you to have a better mechanical connection, and actually when you're going to go on and put solder on the pad, the heat is going to dissipate a lot faster. So we are going to define here, and this one was 0.7 if I remember well. So we have both our pads defined, both have names like the other ones. I'm going to name them add 1 and add 2. Yeah, probably 7.6. Yeah, it's 7.6. So we are going to, yep. Yeah, it's usually after the second decimal place it gets rounded, because even the fab house will actually increase when you are going to send the Gerber files. The holes are going to be increased by a certain amount because they're going to get plated, and when they are going to get plated, if they will use the values that you are going to specify, the holes will be smaller than the ones that you designed. So they will actually enlarge the hole by a certain amount, usually by 10 mils, and they have to take into account the plating. Okay, so you have defined both of the pads. Let's see, 35. We have 5 more minutes. Okay. And after that, you can go on and define the device. And a device, as I told you, okay, new dev, is made out of the 2 components, and 2 components are those that we defined earlier. Okay, remaining meeting time is 3 minutes 23. I will be able to pull this out. So what you are going to do is you have to go on. Sorry, you have to go on and add a symbol. Okay, and sorry for this. And you are going to add a package. After you added a symbol and a package, you will have to connect the pins and define the electrical connection between the pins of the symbol and the pads of the PCB footprint. And that you are going to do by double-clicking here. And now you'll see why I've changed the names of the pads, because it will be easier to see how you are going to connect, because we are going to connect by clicking the pad name. You are going to connect the pad one, the pin 1 to the pad 1, and just double click. And we are going to connect the pin 2 to pad 2, just double click. That's it, that's all. And you will have a fully defined symbol here. I'm going to explain why the G USD, US dollar sign, it's going to appear here all the time, and that's because a certain symbol can have many gates. That will be many functional blocks, but we are going to get there soon enough. So after you define your symbol in the library, you go on and save it. Okay, so we're having 1 more minute till the end of the session, and I'm going to put a cork in it right now